So a strong acid is an acid when dissolved in water fully dissociate or fully gives up all the hydrogen ion. And a weak acid is one that partially gives up its hydrogen ion. So we have some examples here: strong acid, hydrochloric acid, nitric acid, hydroiodic, perchloric, chloric acid. These are strong acids. They are said to be strong because in water they fully dissociate. If you were to draw a dissociation equation, it has to be a one-way arrow indicating a forward reaction. There won't be any backward or reverse reaction.
Next side. So you can move it down.
Okay, a weak acid is one that partly dissociates. For example, ethanoic acid in water, ethanoic acid will partly dissociate. It will give up some of its hydrogen ion and will still hold back some. So if you were to write equation, the symbol of ethanoic acid in water with a forward and reversible sign here. It means ethanoic acid in water can give off hydrogen ion, but it can be reversible, can take back the hydrogen ion. So it's said to be a weak acid because it partly dissociates. You know, unmute yourself. Someone is unmuting and I think conversation. Okay. Questions in line with strong and weak acids. Explain why, if I ask you, explain why hydrochloric acid is strong and ethanoic acid is a weak acid, your answer would be hydrochloric acid is said to be a strong acid because hydrochloric acid fully dissociates in water, and ethanoic acid is a weak acid because it partly dissociates in water. Question 2. Which of the following acid is strong and which one is weak? Acid. You have citric and nitric acid. Citric acid is found in lemon. Citric acid is a weak acid. Nitric acid is a man-made acid and nitric acid is a strong acid. Why? Because in water, nitric acid will fully dissociate, citric partly dissociate. Concentrated and dilute. The word concentrated and dilute is different from strong and weak. So let's say hydrochloric acid is a strong acid. Hydrochloric acid can be concentrated and it can also be diluted. Okay. Concentration. A concentrated solution contains large amount of a solid per liter of the solution. For example, let's say cordial, the one bought when you buy a cordial, the one that is straight from store is more concentrated. That means the cordial particle is higher than water. Before you drink cordial, you will have to dilute it by adding water. So more water particle compared to cordial is dilute. So a dilute solution contains small amount of the solid, the compound dissolved in water, and more amount of water. So concentration depends on the ratio of water compared to the compound solvent dissolved in the solid. Solvent refers to, can be a solid or a liquid, and solid is liquid being dissolved in, for example, water. So hydrochloric acid can be concentrated and can also be dilute. But hydrochloric acid is still a strong acid because it fully dissociates in water. Okay, some uses of acid. There are some in your textbook. I have some on board here. Sulfuric acid is used in detergent, car batteries, ethanoic acid in vinegar to preserve food, adhesive, glue, hydrochloric acid, in cleaning metals and leather processing. I hope you are concentrating. Common properties of acids and bases. Sorry, acids. All acids, they have sour taste. So when we come to, when you compare acids to bases, you can differentiate. So try not to forget acids, they taste sour. They do not feel slippery. They have a pH level, pH range less than 7. 7 is neutral. They release hydrogen ion. When dissolved in water or in aqueous solution, they corrode metals. They react with metals to produce a compound and hydrogen gas. They turn litmus red or pink. So these are common properties of acids.
Please, no.
Okay, I'll stop here.
After
We'll
5
come back after 5
minutes.
minutes. Thank you.